Welcome to the video for Lesson 5 of the Turn the Lights On curriculum. In Lessons 3 and 4, we looked at fossil fuel power plants, hydropower plants, and wind turbines. In this lesson, students will learn the concepts of radiant energy and how solar panels are used to generate electricity. This will be the fourth type of electricity generation system that they will learn about for their design. As with previous lessons, in this video, we will just go step by step through the lesson. The details about the activities can be found in the activity video for Lesson 5. At the end of this lesson, students will be able to comprehend that solar radiation is energy made up of different wavelengths, and relate the light's wavelength with the amount of electrical current produced by the solar panel. This lesson can be completed in one 50-minute class period, so let's get started with the introduction of the lesson. The two main concepts in this lesson are related to characteristics of light and the use of solar energy for electricity generation. However, let us first revisit our engineering design problem and see how the science concepts in this lesson can help us move forward in the design process. Use the engineering design process poster and students' engineering design process sliders to help students identify what they have done so far and what step they are currently on. To discuss what the students have done so far, remind them of the concepts from previous lessons: chemical energy in the context of fossil fuel power plants, and kinetic energy in the case of wind and hydro power plants. Hopefully, students will be able to identify that they are in the learn phase of the design process. If students are unable to get to this answer, ask them guiding questions such as, do we have everything we need to make the plan? If not, do we still need to learn more? Go over the graphic of the learn phase with the students to help them identify what questions they have or need to ask before the class is introduced to the concept of solar energy. If students come up with these questions about understanding and measuring electricity produced from solar energy, then they will be able to see the relevance of the activities which you will do in this lesson. The wave-particle duality of light is a difficult concept for students and people in general. In this lesson, students will be introduced to this phenomenon. To help you understand and better explain this concept, the curriculum has a link to a video about the dual nature of light. You can pause here and watch that video or watch it later. You will find the link below. Based on your experiences in teaching science, you can spend additional time reviewing other parts of this lesson that students may have difficulty with. It is likely that your students have learned about solar energy before or seen solar panels being used around them. Ask students what they know about solar energy and use this discussion to connect the previous topic of characteristics of light to solar energy and electricity generation using solar panels. Remind students about the discussion you had about effects of using fossil fuels in Lesson 2, and ask them to similarly think about different benefits or limitations of using solar panels in the context of our engineering problem. Building these connections between previous and future lessons will help orient students as they go through the Turn the Lights On curriculum. The working principles of solar panels are challenging for students. You can use analogies, such as photosynthesis, to make it easier for them. Explain to students that the sun produces light in all wavelengths, and each wavelength has a different amount of radiant energy. This energy is absorbed by photovoltaic solar panels and transformed into electrical current. The experiments in this lesson will help students understand this concept better. The activities in this lesson will focus on understanding the different wavelengths of light and how varying wavelengths are absorbed by the photovoltaic cells to produce different levels of electrical energy. In this video, we will only look at the pedagogical aspects of these activities. For the step-by-step video of how to conduct these activities, you can check the activity video for this lesson, which is given below. The first activity involves some mathematics calculations. Here, the students will use the formula to calculate the radiation energy of different wavelengths, which is given in the curriculum. Have the students populate the table given in Worksheet 5A. This activity may be demanding for students with a limited mathematics and physics background. If you prefer, you can skip the calculation of the energy and instead focus on explaining that energy is proportional to a very tiny number called h, which is Planck's constant, and the color of the light is its frequency. This phenomenon is governed by the equation energy equals Planck's constant times frequency. After the calculation, tell students that we are going to do an experiment with a real solar panel to see how different wavelengths or frequencies can generate different amounts of electrical current. This experiment is covered in part 2 of the activity video for lesson 5. You will find the link below for this video. You can pause now to go and watch it or watch it after this video. Ask students to explain how a solar panel can be used to light up an LED. Use the students' responses to briefly remind the students of the 3 properties of any wave: reflection, refraction, and absorption. Tell them that the radiant energy from the bulb light interacts with the solar panel. The panel absorbs light at specific wavelengths to produce the movement of electrons and turn on the LED. At the end of this activity, ask students what they learned about radiant energy. Then summarize by telling them that the light from the sun is made up of different wavelengths. These different wavelengths vary in energy levels. According to these different energy levels, the solar panel produces less or more electrical energy. You can close up this section by asking a few extra reflection questions, like which wavelength produced the greatest and least amount of current? And how does this information help us improve our design? At the end of the activities, have students reflect on how this new knowledge about solar panels helps us in our design of an electrical generation system. Ask students to think about where they can locate the solar panels of our electrical power generating system on the map. Help students to connect the science concepts with their prototype and ask them to finish the worksheet 5B. For example, they can think about positioning the solar panels in places where the radiant or light energy is maximum, thus the maximum energy can be obtained. To conclude the lesson, tell students that in this lesson we have learned a little bit about radiant energy and the use of solar panels for electricity generation. With this, we now know about different ways to generate electricity using fossil fuels, wind turbines, hydropower, or solar panels. In the next lesson, we're going to look at environmental impacts of the different types of power generation. Finally, take some time now to plan for how you will implement Lesson 5. Focus on the difficult concepts that are related to radiant energy and solar panels. You might want to take notes in your curriculum document about the things you want to remember, and perhaps add information about timestamps from this video that may help you later when you want to review. When you are ready, proceed to the Lesson 6 video.